All right, welcome to Review Week Lessons 2's video. Again, for this video, we're going to go through 5 of the problems, and then you'll go on the classroom and hopefully be able to answer the Lesson 2 problems, which there will be 5 of, and they will be very similar to this. To help you do that, while you're watching this video, you should be taking notes, just like you would do in class, ideally with the pen and paper, because the act of writing will help you uh, remember this stuff when you have to use it for the ACT or in future classes, or possibly even your career. Okay, first question that we're going to go over is picking up from where we left off from the last video is number 6. Solve 5 sine theta is equal to -1, where your answer has to be between 0 degrees and 360 degrees. In order to do this, we want to solve this for theta, which means I want to get theta by itself. To get theta by itself, it's going to be 2 steps. I need to get rid of this sign, and I need to get rid of the 5. Getting rid of the 5 is easy, right? Because right now I have 5 times the sine of theta. So the opposite of multiplying by 5 would be to divide. So my first line is going to be the sine of theta is equal to -1 over 5. All right, second thing I need to do is get rid of the sine function so I can have theta by itself. To do that, I take its inverse. If I do the inverse sine of both sides, on the left side it'll cancel, and on the right side I will get this. Now this is not going to give us an exact answer. That's not one of your ratios from the unit circle, and that's fine anyway because we're going to write our answer to the nearest thousands. So to actually calculate that is, we're going to need our calculator. This needs to be in degree mode, and it is. And then we're going to do second sine. That'll pull up the sine inverse function of -1 divided by 5. And that is -11.537 degrees. There it is. So this is going to be about -11.537 degrees. Now there's an issue with this. This is not going to be one of the answers to our problem because it is not between 0 and 360 degrees. This is an angle in quadrant 4. So I need to find the angle in quadrant 4 that's between 0 to 360 degrees that is coterminal with this angle. So in order to find that, I'm going to take -11.537 degrees and add 360 degrees to it. And if you did that, you will get about 348.463 degrees. Again, the idea here is if you think about your unit coordinate plane, here is -14 degrees. That, again, is not between 0 and 360 because it's a negative number. So I need to find this angle right here that stops at that same spot, but is not the negative angle, rather it's the positive angle. So to find that coterminal angle, you just add or subtract 360 degrees, because this time I want to make this negative number into a positive. I'm going to add 360. Again, this is not done though. This is the answer in quadrant 4. But that is not the only answer that will have this ratio of -1 over 5. Remember, the sine of an angle is y over r. It will be negative whenever y is negative, and y is negative when it's below the x-axis, which happens in quadrant 4, but also in quadrant 3. So we're going to have 2 answers to this problem. To find the answer in quadrant 3, all right, let me draw a new picture over here so you can see that. To find the answer in quadrant 3, what I have to do is find this angle here, which is going to be 180 degrees plus whatever this little bit here is after I pass the x-axis. That little bit we call the reference angle. Notice that this little bit here is the same angle as we had over here, except it's positive, not negative. So this 11.537 is our reference angle if we change it to positive. So to find, again, that angle in quadrant 3, I need to know what the reference angle is. It's the same as this angle except positive. And I'm going to take this reference angle and add it with 180. So my second answer will be 180 plus 11.537 degrees, which is about 191.537 degrees. Okay, if it helps, you can refer to your notes for all that information on all these rules to remember it for cosine tangent. I'll go over them really briefly if you like. In the first quadrant, all of them are in positive. In the second quadrant, the only trig functions that are positive are sine and cosecant. In the third quadrant, the only trig functions that are positive are tangent and cotangent. And in the fourth quadrant, the only trig functions that are positive are cosine and secant. If you want to find your reference angles to find those other answers, oh, hold on, let me just erase some of this stuff over here. To find the reference angles, again, you have these in your notes already, but I'll rewrite them for you. In the 4 quadrants, in quadrant 1, your angle here is the same as your reference angle. Those are the same thing. In quadrant 2, your angle is 180 degrees minus your reference angle. Because again, your angle is this. The reference angle is just that little bit right there. So it's almost to 180 minus whatever little bit is left out over here. In quadrant 3, your angle is 180 plus the reference angle, right? We just did that. This angle right here is 180 degrees plus this reference angle, or this little bit right here. And then in quadrant 4, we can do a similar trick. It's almost all the way to 360, but it falls short by this little bit. So our angle is 360 minus the reference angle. So those are how you find your angle. Those are the equations that relate your central angle to your reference angle in quadrants 1, 2, 3, and 4. Okay. Now let's move on to number 7. For number 7, we are told to solve this again, so that means to get x by itself. In order to get x by itself, it's the same steps as before with one extra. I also need to get rid of this 3. But that's easy. To get rid of the 3, instead of a positive 3 here, I would subtract 3. That'll make that 0, which eliminates it. So that'll give us 4. I'll divide both sides by -2. That'll give us -2. And then I need to take the cosecant inverse of -2. Now, you'll notice on your calculator you don't have a cosecant inverse function, but we do know cosecant is the reciprocal of sine. So this is the same thing as the sine inverse of -1/2, right? Instead of -2/1, I flip the fraction because they're reciprocals of each other, and then do sine inverse instead because that's the one that my calculator will accept. And then we're basically going to run through the exact same thing we just did. We're going to do the sine inverse of -0.5, and that is -30 degrees. Oh, radians. So we got to change the mode to radians. So it's really -5.24 radians. Okay, so did I write that correctly? Did I say that right? That doesn't sound right. Negative 5.24. Okay, yeah, I said it right. Okay. Um, so now that we've got that, remember that that's in quadrant 4, and it's supposed to be a positive angle, not a negative. So to find the real first answer to this, I'm going to take that answer and I'm going to add not 360 degrees this time, because since we're in radians, I need to add the equivalent in radians, which would be 2 pi, which gives me about 5.761. Is that right? Plus 2 pi. 5.761 or 60. 5.760. Okay, but that is the answer in quadrant 4. That's not the only time when sine is negative. Sine, as we just learned, is also negative in quadrant 3. To find an answer in quadrant 3, I take, again, 180 degrees plus my reference angle. But since we're in radians, that's really going to be pi plus our reference angle. So our second answer here will be our reference angle, which is positive 0.524 plus pi, which is about 3.665 radians. So this is my first answer in quadrant 4, my second answer in quadrant 3. All right. As a reminder, by the way, whenever you're doing any of these and you're not sure if you did it correctly, you could go to desmos.com and type in your equation, 3 minus 2 cosecant x. And the left side of your equation is 1, and then the right side of your equation as another. And then make sure, I have to move my face here, make sure in the settings that you're in radians or degrees as appropriate to the problem. But then you can click on these intersection points and double check that 7 pi over 6 and 11 pi over 6 are really the answers that you got. So like, for example, 11 pi divided by 6 is 5.7595865532. So those are the same answer. So whenever you're doing those, you can check and make sure that you got the right answer. All right, number 8. Number 8, we're still on the same thing. This is going to be an exact answer though. So to find this, I need to get x by itself. To get x by itself, I need to divide by 2, which will give me the cosine of 2x is equal to the square root of 3 over 2. To get rid of cosine, I will take the inverse cosine of square root of 3 over 2. And then I'm asked to give this answer in radians. So you could, if you don't have it, since we're supposed to give exact answers, you could find a unit circle chart by just Googling it and clicking images. There's tons of them out there for you. But really, if you know your special right triangles, that's all this is, right? Like at 30, 45, and 60, those are your 30, 60, 90 triangles, and your 45, 45, 90 triangles, and their ratios between their sides. So for this one, we're asked to find their cosine inverse is the square root of 3 over 2. So what angle gives us a square root of 3 over 2 for our x? Because it's cosine. And that would be at pi over 6. So we're going to write that 2, my first answer, let me change this back to draw. My first answer is when 2x could be equal to pi over 6, right? If I take the cosine inverse of square root of 3 over 2, I get pi over 6. And that's what's equal to 2x. So to solve this for x, I would divide by 2, which would mean a half of pi over 6 is pi over 12. That's just the first answer. I have to ask, in what other quadrant is cosine positive? Well, cosine is positive when, since cosine of an angle is x over r, it is positive when x is positive. X is positive when you are to the right of the y-axis, which is in quadrant 1 and quadrant 4. So I need to find my answer in quadrant 4. To find the answer in quadrant 4, it's going to be 2 pi minus my reference angle. And this is my reference angle. So my second answer will be when 2 pi minus pi over 6. That needs a common denominator. So if I get a denominator of 6 over here, 2 times 6 is 12. 12 pi over 6 is the same thing as 2 pi over 6. 12 divided by 6 is 2. 12 pi over 6 minus 1 pi over 6 is 11 pi's over 6. And now to get x by itself, I would divide by 2. So my second answer is 11 pi over 12. Okay, you might say that you're done here, but you're not. The issue is, I'm going to have to move my face to do the other answers here. The issue is this are answers for when x is between 0 to 2 pi. We're finding the cosine inverse that gives us 2x. So if x is in between 0 and 2 pi, then 2x is in between 0 and 4 pi, right? 0 times 2 is 0, x times 2 is 2x, 2 pi times 2 is 4 pi. So I need to find not only the answers really where cosine inverse of square root of 3 over 2 satisfies uh, uh, what angles produce that ratio between 0 to 2 pi, but I also need to find the answers between 2 pi to 4 pi. So there's going to be 2 more. To find those 2 more, I'm going to take this original answers here, pi over 6 and 11 pi over 6, and I want to find the coterminal angles with those. So I'll add 2 pi. So my third answer will be 2 pi plus pi over 6, which is the same thing as, again, 12 pi over 6 plus 1 pi is 13 pi over 6, which gives us the answer, divide by 2, gives us the answer 13 pi over 12. So that's my third answer. To get the fourth answer, again, remember I'm using this before I divided by 2. My fourth answer will be when 11 pi over 6 plus 2 pi. Again, 2 pi is the same thing as 12 pi over 6 plus 11 pi over 6 is 12 plus 11 is 23 pi over 6. Divide by 2. Fourth answer is 23 pi over 12. Okay, and this is another one where you might say, I'm not sure I got all the correct answers, or if there's supposed to be more than these, how could I check if I did this correctly? Well, you just go to Desmos, we type in 2 cosine of 2x, we type in y equals the square root of 3 over 2. Okay, make sure I type that in. 2 cosine of 2x. Oh, too far. Here we go. Okay, and then clear this drawings, and then I can check their intersection points. Here, 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 and here, and see if those are right. You could check this one as well, but you'll notice that 6.845 is larger than 2 pi, right? 2 times 3.14 is 6.28. So that fifth answer would fall outside of the range. And this answer over here would be less than 0. So there's only going to be 4 answers. And then I could go ahead and divide pi over 6 and all of those to check them. But, they work out. Okay, number 9. So for number 9, we're supposed to graph this. In order to graph this, you have to recognize that this is your amplitude, and this value, so your equation here is in the form y equals a cosine of b over bx. A is the absolute value of a is the amplitude, and the period is 2 pi divided by b. So in our problem, it's going to be 2 pi divided by 2, which is just pi. So what this tells me is that this graph is going to oscillate between +3 and -3, and it will repeat that every pi cycles. And then you have to remember, how does a cosine graph work? So cosine graphs start at the top, right? If you think at 0 degrees on your unit circle, why am I gesturing with my hands? You don't need it. Okay, here's the unit circle, right? All right, at 0 degrees, we start at the point 1, 0. So x is at the highest it can be, 1, and then it goes to 0, goes to -1, goes to 0, back to 1. So that's cosine graphs start at the top, and then it's going to complete this cycle pi units later. Halfway between those, it'll be at the lowest point, and halfway between those, or at my quarter points here, it'll be 0. So again, we go maximum 0, maximum -0, back to the top. So it'll look something like this. Make sure it's nice and curved. This is not a V. No sharp points there. All right, and then we can go ahead and complete that again. So between pi to 2 pi, every pi, it's going to complete the cycle. Halfway through, it's going to be at its lowest point. Quarter points here, it's going to be at 0. Ooh, golly. There we go. Looks great. And the only thing that changes if this was a sine graph is instead of starting at the top, it would start at the middle, and then it would go up, middle, down, middle, up, middle, down, middle. But again, if this is one that you're not sure, if you don't remember what sine and cosine graphs look like, you could go on Desmos to graph it and check your answer. All right, last one. Solve cosine of x is equal to 2 sine of x for give answer to the nearest thousand. All right, so in order to solve this, it's going to be similar to how you do all of your rest of your algebra problems. I need to solve this for x, so I need to get x by itself. The problem is I have an x on the left and the right side of this equation, and to fix that problem, I need to get all my x on the left, all my numbers on the right. So to move this x over, I'm going to have to divide by the sine of x. I can't just get rid of this x here yet, or get rid of the sign yet, because again, I mean, you could, I suppose, but I don't know if it would help you. Because it's embedded in that sine function. So to move it over here, I would divide by sine. And then you'll notice, hopefully, something when you do that. Cosine divided by sine, well, that's just cotangent, right? Tangent is sine over cosine. Cotangent is cosine over sine. So I could really simplify this problem. That just becomes the cotangent of x is equal to 2. To get x by itself and get rid of the cotangent here, I would do the inverse. But again, because your calculator doesn't have a cotangent inverse button, instead, I'm going to type this into the calculator as the tangent inverse of not 2 over 1, but as 1 over 2. And then they say it's in radian. So when I type this into the calculator, I need to make sure my calculator is in radian mode, which it is. So I'm going to do the tangent inverse of 1 over 2. And I get 0.464. Oop, back to draw. Okay, that's not the only answer though, right? Tangent is positive in the first quadrant, but it is also positive in the third quadrant. In order to find an answer in the third quadrant, I am going to take 180 degrees, or in this case, pi radians, and add my reference angle, 0.464, and that is going to be about 3.605. So those are my two answers. And again, I could check those on Desmos. Or really, if I wanted to, I could substitute those back in with my calculator and see if the left side of the equation really turns out to be the same as the right side of the equation. And for this one, it should. All right, that ends lesson 2. Feel free to use this when you're solving your problems, to pause, play it alongside when you're working on yours. But really, hopefully, if you've been writing notes this whole time, you should be able to do those problems hopefully relatively quickly, and you won't need to go back and watch this video too many times. All right, thank you all. Good luck. If you have any questions, remember you can stop by my office hours or send me an email.